Assalamualaikum. Nama saya Aina Munira. Saya dari program UR6523 dan hari ini saya akan bentangkan assignment 2. Okay, soalan 1 dia pasal full adder. Dia bagi input 111 untuk A. So kita tulis 111 dekat A. Lepas tu untuk input B dia bagi 101. Kita tulis 101 dekat input B. C untuk first output kosong sebab belum masuk apa-apa lagi, belum ada carry out lagi. Satu di adder yang pertama, half adder yang pertama, 1 tambah 1, 1 kosong, 1. Nilai 1 tu letak dekat C out, nilai kosong tu letak dekat sum 1. Lepas tu dia carry in C out tu kepada C in 1. Masuk yang kedua, half adder yang kedua, 1 tambah kosong tambah 1. 1 tambah kosong tambah 1, 1 kosong. 1 letak dekat C out, kosong letak dekat sum 2. 1 dekat C out 2. Okay, next untuk half adder yang ketiga, C in dia carry daripada C out. Half adder kedua itu 1. Input dia 1 tambah 1 tambah 1, 1 1. Okay, 1 dekat sum yang ketiga. 1 lagi untuk C out ataupun C yang keempat. Okay, itu aja. Okay, soalan 2 dia nak sum of product for the sum and C out. Yang pertama kita highlight dulu lah. Okay, kita highlight dulu yang mana yang ada high output value. Okay, sekarang kita highlight value untuk high output untuk C out. Okay, dapat dah. Sekarang kita tulis dia punya sum. We will write the sum. Okay, tulis number tepi tu nak bagi senang. Anything that has the low output value, 0 output value, Make it not. Okay, for C up, sum for C up. Okay, this is for the K map for sum zeros. Okay, this is the K map for C out. Now let's draw the circuit. First circuit is using the inverter circuit. The inverter circuit is for the sum of products. We will use an AND gate for every output. And then for an inverter circuit, put the NOT, the inverter, so that the value will be A naught and B naught. I'm just gonna write it there so I know what to draw. For the second expression is A naught, B naught, and C. C naught here. The next expression is A B naught and C naught C, not C naught C. And let's see, the next expression is A, B, and C. And let's say combine them with an OR gate so that we get the sum output. Okay, next, for C out circuit, we are going to use AND and OR logic circuit. So the expression AC, BC, AB, AB, BC, and AC, all of them are using AND gate. Right. Then connect them to the OR gate so that we get the output, C out output. Okay, that's all for question number 2. Next, we have question 3. Question 3, we need to sketch the 4-bit parallel adder and output carry for the addition of the following two 4-bit inputs. If the output carry C is 0. So we need to draw the 4 adders in parallel. So you see, we need to draw 4-bit parallel adders. So we need 2 half adders times 2. So it equals to 4-bit parallel adder. Okay, now we need to insert the output for A, A1, A2, A3, and A4. Then we draw output B1, B2, B3, B4. C1, C2, C3, C4. And let's see C out. Sum 1, sum 2, sum 3, sum 4. Now let's insert the input for A, which is 0, 1, 0, and 0. I mean 1. Insert input for B, 1, 0, 0, 1. C1, 0, start with 0. Then we do the addition. 0 plus 1 is 0. 0 plus 1 is 1. 0 plus 1 is 0, 1. Put 0 at C2 and 1 at sum 1. Okay. 0 will be carried into the next adder. Do the summation. 0 plus 1 plus 0, 0, 1, 3, 0, S2, 1, 0, 0. So carry out 0, sum 0. 1 plus 1 plus 0 is 1, 0. C out 0, sum 0. For the truth table, we have input A, input B, and C in. And for the output, we have sum and C out. Okay, since there are 3 inputs, so we are using the 8-bit. Just insert the value according to the diagram, the input diagram. Okay, same steps goes for the output. Just follow. what I've written in the diagram. Now write the sum output, sum expression for the output. Okay, that's all for question 3. Okay, for question number 4, we need to design a for one multiplexer by showing the truth table and Boolean expression. From the question, it shows for one multiplexer with 4 inputs, input 1, input 0, input 2, input 3. And then there is sum 1 and sum 2. And output y. So now let's draw the truth table. Okay, since this is a multiplexer, so we need to end the value of both of the sums, sum 1 and sum 0, so that you can end it with the input value of 0, I0, I1, I2 and I3 to get output y after all the AND circuit will combine with an OR logic. So we get the Boolean expression written like this. Okay, now to draw a 8-1 multiplexer using 4 multiplexer. We need to use 2 4-1 multiplexers to combine into a 1-8-1 multiplexer. So we draw the input 0, input 1, input 2, input 3. Sum 1, sum 2. And draw another multiplexer for one multiplexer. Input 1, input 2, input 3. And then combine S1 and sum 1 and sum 2 with the other multiplexer, then and then use a 2-1 multiplexer to get the output Y. Combine both of the 4-1 multiplexer, and then you get a 8-1 multiplexer using 2-4-1 multiplexers. Now we move on to question number 5. The question shows a 2-bit comparator with 4 outputs, and then there are 2 outputs for this comparator in which X is greater than Y, or the other one, X is equal than Y. These output each will give an output value of 1 if the comparison value is true. Okay, so it has 2 outputs, X and Y. Okay, we have an input X0, X1, Y0, Y1, and the output will be either X is greater than Y or X equals to Y. So we have to compare the X input, both of the X input and both of the Y input in order to get the output either 0 or 1, either if it's true or false. So let's draw the truth table. We are using a 16-bit because there are four inputs. Okay, so I write the value in decimal so that it's easier to compare. Okay, now we are going to start comparing. So for X is greater than Y, 0, 0, 0. Are they the same? X equals to Y? Yes, so put 1. Next, 0, 1. X equals to Y? No, 0. Are X greater than Y? Also no, which is, so we put 0. So put 0, 2, 0. Is 0 greater than 2? No, 0. 0, 3. 0, 0. Is 1 greater than 0? Yes. Equal, no. 1, 1, 0. 1, 2, 0. 1, 1, 3, 0, 0. 2, 0. 0, 0. 2, 1. 1, 0. 2, 2. 1, 0. Okay, now we get the truth table values. Next, we are going to draw the K-map. K-map for is X greater than Y. So I highlight the output value. We have the high output, which is 1. Now we get the Boolean expression for x is greater than y. Now we are going to draw the K-map for x equals to y. So we highlight the x equal to y output, which has a high value. And now we get the Boolean expression for x equals to y. Okay, end of question 5. Okay, for question number 8, we need to design a decoder that accepts 3 bits input and displays alphabet at the 7 segments. Okay, the input we need to get, the output we need to get from the input 000 is the alphabet A. Input 001 for alphabet H. Input 010 for alphabet 0. Input 011 for alphabet U. Input 100 for alphabet L. And the rest are don't care. So in order to achieve the right output, we have to make a truth table that satisfy the conditions need to form the alphabet on the LED 7 segment display. So now we are going to illustrate how the LED segment would look like. Okay, we will label the segments as A, B, C, D, E, F, G, starting from right to left. So we have 5 sets of 7 segments so that we can produce the letter A, H, O, U, L. And then I will label each segment that has an output, that will produce an output of each letter, that will produce an output so that it displays the letter properly. Now we will sort the output according to the alphabet A, B, C, D, E, F, G. For each segment that displays a part of the letter, it will produce an output 1. If not, put 0. Now we produce the truth table. Okay, write out the input first, x2, x1, x0, and then rewrite the output we get for each letters. Now that we have the truth table, it's time to write the summation. Now draw the K-map for each letter. And write out the Boolean equation.